In this module, we'll look at what cloud computing is and why it's important and why we're studying it in this course. If we look at a standards organization like the U.S. National Institutes of Standards and Technology, they have a definition of cloud computing that I'll quote. They say it's a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, example, network, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. I've provided the link to this definition, and also in your readings you'll see a bigger report that NIST made about cloud computing architectures. But let's look at the essential characteristics of cloud computing. So what distinguishes cloud computing from other types of computing? The first is there's on-demand self-service. So this is not orchestrated necessarily for you. It's architected by a provider, but you serve yourself. And it's always there. It's on demand. It's like a utility. So often you'll hear people talk about it as a utility like electricity or water. There's broad network access. The whole essence of this is that you're going to go over the internet to get access to these resources. There's resource pooling. This is the idea that you're sharing a huge pool of resources. So some of the cloud providers have immense resources, and you get access to them. So you do not have to provide the hardware, software yourself. There's rapid elasticity or expansion. In other words, this system can be constantly upgraded, constantly extended, and it doesn't impact on people who are already running their services, their programs on the cloud. And it's a measured service. So in other words, what you use is being measured. So nothing is free in life. So obviously you're going to have to be charged for your use of this hardware and software. And so it's going to be measured out. Now, is cloud important? Well, it probably has impacted your life already. So have you ever used Netflix, Amazon Prime, Google Drive, Dropbox, any of the storage facilities, Spotify, Apple Music, Amazon Music, Google Play Music? They're all cloud provision. So anytime you're streaming video, you're streaming music, you're storing things in a central repository, these are all possible because of cloud computing. Cloud, you'll find in the news all the time. This is actually, it's impacted not just the technical community, it's impacted the community as a whole. So I've picked out a few news articles here that are generally meant for the public. So in one, cloud computing is being talked about as crucial to the future of societies. This other one, a particular government, the Scottish government, wants to boost national cloud uptake. So this is a little bit strange that you have at the government level, people talking about why cloud computing is important. In the information technology world, you also see changes because of cloud computing. So we've got an article here, a recent one, where the Amazon Web Services, their cloud platform, had a denial of service attack that was 40% larger than any previous attack that's ever been known, and they didn't go down. So this was a huge 2.3 terabytes per second denial of service attack. This was way bigger than anything else, and it stayed up. Now, in fact, if you look at this article, you'll also see that they're talking about at the same time that Azure, the Microsoft cloud platform, did go down. So it's not like cloud is impervious to problems or attacks, but the cloud platforms are fairly robust. And if you look at where cloud is going, you'll see all the different services that are being unveiled. I've just picked a couple out because they're probably in the more sexy or sort of new trendy type of business segment. We have Amazon Web Services unveiling a new space business segment. And you also have them allowing you to explore and experiment with quantum computing. And they even offer you the ability to run on what's purported to be a quantum computer from D-Wave. There's many different groups online that are tracking cloud computing, providing resources about it, having technical talks about it. This is just one of them that I picked out, but it has lots of different blogs and information about cloud technology. Now, in this course, we're going to be looking at primarily the big cloud providers. So if we look at, this is a graphic that's looking at, and this is only up to the first quarter of 2018, but the proportions are still similar about the different public cloud platforms. So you have Amazon, Microsoft, IBM, Google, Alibaba. These are starting at the lower end to sort of move around in position, but by far the largest provider of cloud resources and services is Amazon. Their next competitor is Microsoft Azure, but as you can see from this graphic, it's not in any way close to the same penetration of the market. Now these are changing around. Google is getting up there more, and you've got the challenger from Chinese business, Alibaba. But right now the major provider is Amazon. So these are called public clouds. So they provide computing, storage, other services to any member of the public with the ability to pay. They're often compared to public utilities, things like water, electric, sewage, roads. Although unlike utilities, they're not regulated, they're not provided primarily by the government. But the biggest names in this, and the ones that we're going to look at in the course, are AWS, Azure, and Google's cloud platform. There are things called private clouds. These are operated by a private institution, or in fact, it could be an individual. They provide computing, storage, and other services, but to a limited audience. So these are generally not ones where you pay to play. These are ones that you're setting up yourself, or you're contracting someone to set up. There is a stack that you can use for the software for these systems. It's called OpenStack. And there's others, but OpenStack is the dominant open source cloud software solution, and it's used by many private clouds. Now, what's the difference between public and private? Why would you go for one or the other? Well, one thing, the public clouds are huge. They are selling you on scale. They have powerful features. They do fine-grained billing. They have very high reliability because they're geographically distributed. This is often a problem with private clouds. If one AWS node goes down, that's in a way trivial to their network because they have so many. They also can provide and provision your services close to your audience because they have data centers all over the globe. These public clouds also provide a wide variety of resource types. We just looked at the fact that they're even starting in a small way to get into quantum. They're trying to get into any field they can. They will provide all sorts of different hardware and software solutions. They have a rich set of services, ones where your programming requirements are small, that you can take advantage of their very large staff and very good staff that provide you with software and services. And they achieve this with a substantial economy of scale. So even while they're not cheap to actually buy their services, for what they're providing, they're actually, particularly with this ability to have reliability due to geographic distribution, it's actually a pretty good deal. private clouds are usually preferred when you have a specific workload. It's very well defined. Maybe it's already been provisioned in software, and you want to use in-house infrastructure called on-premise or on-prem. You'll hear people talk about that. And a lot of times that's because a lot of organizations believe that they cannot trust sensitive data or sensitive functions to an organization outside of their own. We'll look later in the course at security, and we'll look at a comparison about whether this perception of security on-prem is actually true. There are things called hybrid clouds, and this is where you're going to combine on-premise IT, and this is usually data being stored where people don't want that data to go off-premise, but they want to use the other resources and services from a public cloud. So you can build your service from a combination of different clouds, on-prem, using different public cloud services. And this is starting to become very popular, particularly when people already have a large investment in on-premise infrastructure. They may not want to give it up. And in fact, some services that were totally in the cloud sometimes drop back to having some things not in the cloud. And there's a very good discussion of this in a small book produced by O'Reilly, Designing and Building a Hybrid Cloud, and I'll make that available for people to read if they're interested in that. That will be on the course link. So you could look at a hybrid as having a 3-tier application stack. So the presentation service, such as a website or an API service, might be on a public cloud. They're easy to get to, they're easy to provision. There's lots of services that allow you to put those up very quickly. The application service might reside on a managed private cloud where you might have database services, and these might reside on the premises. So you have all of these different layers that you can take into account when you're doing a hybrid. Now, there's also another way of categorizing cloud services or cloud infrastructure, and that's by their usage. So there's 3 very popular ones, although there's others coming up, and I'll talk about them later in the course. So the first one is infrastructure as a service. This is where you have on-demand computing and storage that you can call upon when you need it. So this can expand or contract, anytime you need. So this is really that you're just using the infrastructure, but you're doing everything else. You don't want to provide all of that storage on premises, or you don't want to have to buy the latest GPU or CPU. And so you're using their infrastructure as a service. There's also the notion of software as a service, where you have powerful software that maybe you can't afford to use, or you don't want to use it all the time, so you don't want to buy it or lease it all the time or license it all the time. And so you're using not just the infrastructure, but using the software that's on that cloud infrastructure to leverage what kind of service you want to provide. And the last one, which is a more recent but becoming more popular, is platform as a service. And this is where you have a collection of powerful software mechanisms that you can use to build software that you might not be able to duplicate on your own. So in fact, in a lot of cases, and we'll look at this, it may be that you actually don't have to do all that much programming at all. In other words, the platform is there. You might just be tuning it or providing parameters for it or providing data for it, but it's already been provisioned. It's already been tested. And so this is very popular for things like artificial intelligence or data mining or any kind of data science, where a lot of the algorithms may be very expensive or hard to produce on your own, particularly training and testing of machine learning algorithms. And so this is the platform itself is provided as a service. So we'll be looking at all of these different categories of use and how you can use them, how you can build things with them, and we'll also later in the course look at some other uses that are becoming more popular.